since we did have it inside our linked list, and we kind of want to be kind of similar as far as how they look, I want to also provide this Boolean kind of type, and I'm going to call it as empty, like what we had. So, you know, we basically, you know, trying to kind of make them look the same. So as if you have similar, because they're all lists, right? So we could have as list interface or list, basically kind of super class, right? So we put all the common things in the super class as well at some point. So we can add the polymorphism into it, basically, in some sense. And that's actually also, we're going to see a slide that Java also do that, right? So we have a list interface in Java that is basically, you can add, you can create any list, array list, linked list, or even set, and add it to that as well. So we're going to see the graph for that and how the hierarchy between different interfaces and abstract classes are until we get to the actual concrete classes. Again, we're just trying to implement our own simple ArrayList at this point to just understand the structure behind it. So the isEmpty method, how we know if the list is empty? If the size, like if you're 100% sure that we're going to maintain the value of the size, so if the size is 0, then we know that basically this is going to be the empty array. Otherwise, we already add some element into it. So the first thing we're going to do, as again, as what we did already, is that adding element to this list, right? So we're going to have a method. Again, all the methods I'm going to add as a void, so they're not going to return anything, and it's going to get the add element into the list. So when you're adding element into the array list, or basically we're trying to add them to the very first empty index. So we started from 0, and then as we keep going, whatever is the value of size, basically that's the one we're going to add element into it. That's normally how we do it. So basically, we kind of, if you think about it, is like adding to the end. If you think about the end of the array, as we increment the value of the index, that's going to be the end of the array, and the beginning of it is when the index is 0. They're kind of similar to adding element to the end of this array. Like, so we're always adding element to the end. If we want to kind of simulate that with what we had in the linked list. So I'm just going to point it out on the top of it, just as a comment. So this is kind of similar to adding element into the end of the list, right? Again, just to kind of compare that concept with what we had in the linked list, so we can later on compare them with each other. So when we're adding element, again, all of our elements at this point are only a string. We didn't add the generic type to it yet. So all the elements, we're getting an element from the user, and then we start adding the element into this list, right? So of course, when we're trying to add element into the list, we just have to know what is the last index, what is the size, and then we're just going to add the element into that size, right? So we basically have to just do this, right? So that's going to be as simple as adding element. Can I use a size here? Is it okay if we do that and then add this element into it? Yes. Any objection, right? Because the size at the beginning is 0, right? And the array is empty. So so I can just basically put it there. And as we add element there, we have to do to maintaining the size, we need to do making sure that we increment the value of the size, right? So the next time that we add the next element, the size is 1, and that's exactly the location that we like to add a next element into the list, right? So basically, this is making sure that we're always adding element to the actual location without having any empty spot in between, right? We don't want to have element and then empty element and then some more elements, right? They're going to be back to back as we increment the index value. So since this is our normal add, it's going to add it to the place that the value of size is. But keep that in mind. We said that we all have to keep track of the value of the capacity and the size. We want to keep track of the ratio of that, right? So immediately as we adding element into this list, when we notice that she's getting close to 100, we need to now double the size of the array, right? So how are we going to do that here? So we already add element to the size. So is there any way that I know if your area is already getting close to the full so we can resize it?
Size is equal to capacity.
Yes, we need to compare the, exactly, we have to compare the capacity and size ratio, right? So exactly that's what we have to do. So I basically have to add an if else statement here, right? So should I add it before or after? Before, right? So before even we add, we need to know if we don't have a space. Then if you don't have a space, then we're gonna increase the space, right? So if you do it after, then you know, basically, even though we may not have adding another element to this list, we automatically increase the size, which is basically like, maybe it's wasting the memory, right? So we wait until a new element actually wanted to be added, and we know that we don't have a space anymore for it. Then we start increasing the size. So now, as your friend says, I have to compare the value of capacity and the value of the size. So if the size is bigger than or equal to capacity, then I know that I need to resize. So in order to do resize, you know, I remember our requirement was that whenever we get to this ratio, and they're basically getting close to be 100%, then we have to increase it based on our requirements to double size, right? So I'm going to have a method called resize here. That's what we're going to implement. And then we're going to, we already know our original capacity, all right? So we're going to pass the capacity, and we're going to, since we want to double size of the capacity, we're basically already automatically, you know, add that value. So we're telling that we need to go and resize this array that we have by default, and we're going to, you know, increase the capacity of it. So now that's, we have to implement the value, or basically the resize method. So since resize method is only going to be used within our class, so we're not going to, you know, call it outside of this class. You know, it's not for our client to use it. It's just locally our methods are going to use it to kind of perform this dynamic capacity of our array list. So it's going to be private, right? So it's only going to be used within this class. So as we already explained, what we have to do exactly in this array, in this method. Remember what we have to do? We have to increase the capacity, and then what else we have to do? So remember, we already have an array that is full, right? And then now we're going to increase this capacity to double size. So what we have to do to make sure we still have all of those elements that we already stored? Exactly. We have to do one by one, copy them back into this new array with the double capacity size. So that's what we're exactly going to do in this resize method. So as your friend suggested, we're going to basically increase the value of capacity to this. I also want to just change this name to capacity to readability, right? Always we want to make sure our methods, names, and also the name of our parameters is clear to understand, so make it readable. So I'm going to now increase the value of the capacity. I already increased it because when we call this method, we tell them that you have to resize and you have to increment the value. So it's going to use that, and then now we have to create this new array, right? So this is what we're going to do. Again, since we just use a string at this point, we're not generic yet. So still I'm going to create another array, and this time I'm going to call it a temporary array because we have to now basically copy all the element back here. So I'm going to create this temporary array, and I'm going to basically copy the element on the list here. So because we don't want to lose that, right? And then I'm going to make sure that I add this new array of this capacity that we just have. I just keep the reference to the old one, and then I create a new one. And as your friend now suggested, we have to now start having a loop, right? Because it's an array. In order to go through each element, you have to have a loop. So we're going to start going through all the elements from this array one by one, and we're going to. So again, that's a you know, another thing I want you to think about it. So I need to go starting from the beginning all the way to some point, and then copy the element into the new array. So should I use capacity here to do the copy, or should I use the size? Which one is better, do you think?
If you use capacity, then shrinking the array will throw it out of bounds.
Exactly, right? So since specifically that we already kind of, you know, we're going to use this method to shrink as well, so we cannot use the capacity. You have to make sure we're using the size, the exact number of the element that we're trying to copy from the old array to the new array. So that's what we're going to do. And so as you know, we do that, we're just going to, now we already have the temporary location that has our old element into it. So we're going to add the old element, which we have in the temporary, into the new element, that new array that we just created one by one from the index 0. So basically, we now copy the element from the old array into the new array, and then now our list basically pointing to this new array that is double capacity size now, instead of just basically exactly like what we originally have. So we basically took care of this, and we're adding elements into our list, you know, and if it's needed, then we'll start increasing the capacity by 2. So now if you want to think about the complexity of this method, just adding element into the list, right? So you know, we just added element to a particular index. How long is going to take us to do that? What is going to be the complexity of this method? Why? Did you have to do any looping? Did you have to go through basically, you know, any particular iterations to be able to add element to a particular index? We just went to that index and put it there, right? So why it's order of n, you think?
Because for every element in the list, it goes up by 1.
Okay, so you're talking about the resize, right? The resize can go all the way to order of n. That's what you mentioned, this one, right? Right? Okay, I'm talking about just the adding, without thinking about the resize itself. Just adding element to a particular index. How long is it going to take us to do that? Order of 1, right? Everybody agree, right? Because we just have to go to that index and put it there. We don't have to do anything else. But in some scenarios, and that's what we're talking about, the overhead, right? If you need to you know, keep resizing, you know, if you don't start with a good capacity and you have to keep calling this resize method, then you're basically adding overhead, especially if you already have an element, a large number of elements into this list, then you're basically adding some overhead. But not, you know, selecting a good capacity for your list from the beginning, and just adding element into this list, right, is going to take us just order of 1. So we're going to also kind of add that here. That is going to just take us order of 1, just to keep that. And again, we're doing all of this to be able to compare this with our original, or with our you know, linked list, so we can see exactly what is going to be the benefit of them and how we can use each of them for, you know, what for a particular reasons. So now we're going to add another method here, and that's going to be removing, right? So we're going to also do exactly what we did inside the linked list, right? So the next thing we're going to add is going to be a method. Again, I'm going to keep all the methods to be void, and that's going to be a remove method. So again, in the remove method, if you want to just remove an element from your list, you're always going to go to whatever, basically, if you consider the higher index to the end of the list, right? So you're always going to go to that place, and the very last element that you have in your list, that's the one that's going to be removed from your list, right? So basically, you know, this is kind of like a natural way that we're using our elements. So whatever you have in the end of the list, we're going to remove it. So that's exactly what we're going to also do. So that means what is the value that we always, like, what is our index at pointing to that last index always? Here. The size is always pointing to where? The element that we have to add, right? So size minus 1 is going to be our very last index, right? The last element that we have in the list. So basically, that's the one we're trying to remove, and we're calling the remove method. So since everything is a string here, if I want to remove, I just basically have to do the size minus 1, and then I'm going to just basically go ahead and say this is going to be back to null, right? Because the strings are reference type, so by default everything here is basically null. And so if I want to do that, I have to increase the value of the size by 1, so I get to the last element. But also, since anyways, we have to maintain the value of size, and every time we're removing element from the size, so I would basically suggest to do that, right? So first I'm going to decrease the value, so we also whatever now I have in the size is the last element that I'm trying to remove it. So that's what I'm going to remove. So we already have this is empty method here, which we can also use. So of course, if if the list is already empty, right, we're not going to remove anything from the list, right? So let's also use that. So we're only going to do this basically if the list is not empty. If it's already empty, that means we're not going to remove anything from the list. So we always like to also give a maybe nice message to our users, right? To tell them that the list is already empty, like what we did linked list, right? So they know that if nothing happened, why this happened, basically what was the reason. So we're going to say the list is empty. Are we done here? Do we have to take care of anything else?
If the thing is smaller.
Yeah, exactly. Back to the same fact that we had the second requirement, right? Remember when we said if you're getting close to 100%, we're going to double size. But we also said if you get close to 25%, right? That means we're using a lot, 75% of our memory for no reason, right? So we're wasting some memory. So we're going to automatically shrink. So again, as I mentioned, the ArrayList implemented in Java is not going to do that because it's basically overhead again. So it's just have a method called trim to size. And so whenever you call it, it's going to trim it to exactly what is the size is. The capacity of size is going to be exactly the same. But just for practice, we decided that our resize method is not only going to grow, it's also going to shrink the array list for us. So in this sense, now if we're getting to the ratio of 25%, then we'd like to be able to call the resize method again. And this time we're trying to resize the value to the half. That's the second requirement we said we're going to have for this array. So where should I put this if-else statement, basically, that I'm looking for it to find the ratio? After we remove or before we remove? Why before? Why not after? Exactly, right? So basically now we know for sure that basically we are losing our memory. So basically after we remove it, now we're doing a check and basically making sure that this ratio is not 25%. This is how I'm going to do it. So I'm going to say this for capacity, ratio to size equal or bigger than or equal to 4, right? That's basically like a 25%. Then we're going to call the resize method again, and this time I'm going to call this capacity that we have, and I'm going to call divided by 2. So that was again our requirement. So anytime that we get to the 25% only, then we're trying to reduce the value to half, right? So we're not going to make it like exactly similar to the capacity. We're just going to reduce it to the half. So again, since we have divided by some value, so I want to make sure and size can be 0 at some point. Although we take care of it by checking that if the element is not empty, but since we remove first, and then we're going to check the resize, so the size can get to the 0. So we have to make sure the size is not 0 before we checking this ratio. Otherwise, we're going to get to the divided by 0 exception. So any objection? Do you guys think it's good enough? If you remember in our linked list, we also, whenever we removed an element, we like to tell our user what was the element that we removed, right? So why not doing the same thing here? How we can do that? You remember what we did in the linked list? We just get to put the element or the value inside a temporary location, and then we print it out, right? So we can do this similar thing here, right? So here, I immediately made it null, but I could basically store it in a temporary place, and then null it, basically make it null, right? So I could basically say the list of acquisition size. And then here, when we're done with our capacity and everything, we're good, then we're going to say that, sorry, we don't have any return, so we're going to say that system.out, and we're going to say temp is this value is removed. And again, so since everything is a string, this temp also going to be in a string parameter. So any objection you guys think we may have? We haven't tested it yet, right? That's the main problem. We need to go back and basically now do some testing to make sure that this array, this basically methods that we implemented in this array is working the way we expected it to work, and the resizing and everything is working. So before we add more code into it. So another thing here is that when we remove, again, we decided that we, basically if we want to compare it again with the linked list, it's kind of like we're removing the element from the end of the list. And what was the complexity of this one? When we remove them, we just went to that index and remove it without considering a resize, which is adding an overhead. So that means it's order of 1 again, right? I guess you guys kind of